Hey guys, welcome back. Tonight we will be exploring one of the most beautiful yet deadly environments in our solar system, the magnificent rings of Saturn. You've seen the pictures, those stunning bands of ice and rock that make Saturn the jewel of our solar system. But what if I told you that surviving even a few minutes in those rings would be virtually impossible? What if I told you that those ethereal, graceful rings are actually a cosmic death trap, moving at speeds that would make a bullet seem slow? Tonight, we're going to take you on a journey through Saturn's rings, and by the end, you'll understand exactly why this breathtaking wonder would spell certain doom for any human brave or foolish enough to venture into its domain. Let's start with the basics. Saturn's rings aren't just pretty decorations floating peacefully around the planet. They're a complex system of billions upon billions of particles, ranging from tiny dust grains, no bigger than a grain of sand, to massive chunks of ice, the size of mountains. These particles orbit Saturn at incredible speeds, creating what appears from a distance to be solid rings, but is actually more like the universe's most dangerous blizzard. Imagine you're part of a space mission in the year 2089. Humanity has finally developed the technology to send crewed missions to the outer planets. Your commander, Sarah Chen, a veteran astronaut with 15 years of experience. But nothing in your training has prepared you for what you're about to face. Your mission is to collect samples from Saturn's rings, something that's never been attempted with a human crew. As your spacecraft, the Prometheus 7, approaches Saturn, you can't help but be mesmerized by the view. The rings stretch out before you like a cosmic highway, their bands clearly defined even from millions of kilometers away. The A ring, the B ring, the C ring. Each one a distinct entity with its own characteristics and dangers. Your mission commander, Dr. James Rodriguez, points out the Cassini division, that dark gap between the A and B rings that looks like a safe highway through the chaos. Don't be fooled by appearances. He warns you over the comm system. That empty space contains more than enough material to shred our ship if we're not careful. Your first challenge becomes apparent as you approach the outer edge of the A. The ring particles aren't stationary. They're moving at orbital velocities. The outer particles in a ring are traveling at about 16 kilometers per second. To put that in perspective, that's over 35,000 miles per hour. A grain of ice, size of a pea, moving at that speed, carries the kinetic energy of a small bomb. Your ship's computer begins calculating trajectories and safe passage routes. The rings might look solid from a distance, but up close, you realize they're more like a three-dimensional cloud of debris. Some particles orbit in neat, organized lanes, while others follow chaotic, intersecting paths that could bring them into collision with your spacecraft at any moment. As you descend toward the ring plane, your radiation detectors start going crazy. Saturn's magnetosphere, the magnetic field that surrounds the planet, traps charged particles and accelerates them to incredible energies. These particles create a radiation environment so hostile that it would cook an unprotected human in minutes. Your ship's shielding is state-of-the-art, but even so, you can feel the slight vibration as high-energy particles slam into the hull. Radiation levels increasing, reports your science officer, Dr. Lisa Park. We're looking at about 50 times the lethal dose for an unprotected human. Thank goodness for the magnetic shielding. But radiation is just the beginning of your problems. As you move closer to the ring plane, you encounter something that no Earth-based simulation could have prepared you for. The gravitational chaos of Saturn's moon system. Tiny moons called shepherd moons orbit within and near the rings, their gravitational influence creating gaps, waves, and resonances that constantly reshape the ring structure. You watch in fascination and growing concern as streams of particles suddenly change direction, accelerated by the gravitational pull of Prometheus, one of Saturn's inner moons. What looked like a clear path just moments ago is now filled with a stream of ice chunks, each one capable of punching a hole through your ship's hull. "We need to adjust course," you announce. But your pilot, Captain Maria Santos, is already on it. The ship's thrusters fire in a complex pattern, nudging you away from the particle stream. But each course correction uses precious fuel. And you're beginning to realize that navigating the rings isn't just dangerous. It's incredibly fuel-intensive. As you finally reach the edge of the ring, you prepare for your first sample collection. The plan seems simple enough. Extend a robotic arm and scoop up some ring particles. But as you watch the arm extend into the ring plane, you're struck by the sheer violence of the environment. Ice particles slam into the collection device with machine gun rapidness, each impact sending vibrations through the ship's structure. Impact rate is beyond our calculations, Dr. Park reports. We're taking hits from particles ranging from dust specks to chunks the size of golf balls. The collection arm is showing stress fractures. You realize that what looks like gentle snowfall from a distance is actually a cosmic sandblaster, the constant bombardment of particles. Even tiny ones would quickly erode any exposed equipment. A human in a spacesuit wouldn't last seconds in this environment. The suit would be shredded by the particle impacts before radiation or cold could even become factors. But the real danger becomes apparent when you try to match velocities with the ring particles to make collection easier. As your ship adjusts its speed to match the orbital velocity of the ring material, you discover something terrifying about the ring environment. It's not stable. What seems like organized, predictable motion from a distance is actually a chaos of competing gravitational influences, collisions, and electromagnetic forces. "We've got a problem," Captain Santos announces. "I'm detecting a resonance wave moving through this section of the ring. The particle density here is so high that in some regions, the ring material is nearly opaque. Light from the sun barely penetrates to the inner regions, creating a twilight environment where navigation becomes extremely difficult. Optical navigation is becoming impossible," Dr. Rodriguez reports. "We're switching to radar and gravitational sensors, but radar has its own problems in the ring environment. The constant presence of ice particles creates a background of radar returns that makes it difficult to distinguish between small particles and larger, potentially dangerous chunks. It's like trying to navigate through a snowstorm where some of the snowflakes are the size of cars. As you move deeper into the B ring, you encounter another phenomenon that no one fully anticipated: electrostatic charging. The constant bombardment of charged particles from Saturn's magnetosphere causes the ring particles and your ship to build up electrical charges. When these charges discharge, they create spectacular displays of electrical activity that dance across the ring plane like aurora. But these discharges aren't just pretty light shows. They're potentially deadly. A major electrostatic discharge could fry your ship's electronics, or create electromagnetic pulses that interfere with your navigation and communication system. We're showing charge buildup on the hull, Dr. Park reports. Recommend we discharge before it reaches critical levels. The ship's electrostatic discharge system fires, creating a brief but brilliant flash as excess charge jumps between the ship and nearby ring particles. For a moment, your immediate vicinity is filled with dancing electrical arcs, a reminder that in Saturn's rings, even the basic physics of electricity and magnetism become weapons against survival. Your sample collection in the B ring proves even more challenging than in the A ring. The higher particle density means more frequent impacts, and the reduced visibility makes it nearly impossible to spot larger, dangerous chunks until they're almost on top of you. Your collection arm takes a beating, and by the time you've gathered your samples, it's showing significant damage. The arm's joint actuators are failing, Captain Santos reports. We might not be able to retract it fully. This creates a new problem. A partially retracted robotic arm would create drag and asymmetric forces as you move through the ring environment. It could throw off your navigation, or worse, get caught on a large ring particle and tear away part of your ship's hull. As you work to jury-rig a solution for the damaged collection arm, you begin to appreciate another aspect of ring survival: the psychological challenge. The constant bombardment of particles creates a never-ending percussion of impacts against your hull. The sound is like being inside a drum during a hailstorm. And after hours of exposure, it begins to wear on your nerves. Is it just me, or is that sound getting louder? You ask. It's not just you, Dr. Park confirms. We're moving into a region with higher particle density. Impact rate has increased by about 30%. The psychological stress of knowing that any moment a larger particle could punch through your hull and depressurize your ship adds another layer to the challenge of ring survival. You find yourself unconsciously holding your breath during periods of particularly intense bombardment, as if somehow that would help if a hull breach occurred. Your mission plan calls for you to next investigate the Cassini division, that seemingly empty gap between the A and B rings. As you approach this region, you allow yourself a moment of hope. Finally, a break from the constant particle bombardment. But as you enter the division, you quickly learn that empty is a relative term in Saturn's rings. The Cassini division isn't truly empty. It contains ring material, just at a much lower density than the main rings. But this creates its own unique hazards. The reduced particle density means that the few particles present are less likely to collide with each other, allowing some of them to maintain highly elliptical or inclined orbits that can take them far from the ring plane. We've got a problem, Captain Santos announces. Radar is showing a large object on an intercept course. It's moving perpendicular to the ring plane. This is something your mission planners never fully considered. In the main rings, particles are kept in neat, organized orbits by constant collisions with their neighbors. In the gaps, some particles are free to follow more chaotic paths, including orbits that can take them well above or below the main ring plane. The object on your screen is a chunk of ice about the size of a small car, and it's moving on an orbit that will bring it directly through your position. Unlike the smaller particles that constantly bombard your ship, this object has enough mass to completely destroy your vessel if it hits. Time to impact, you ask. 17 minutes, comes the reply. You have a choice. Try to outrun the object or change course to avoid it. But both options come with risks. Accelerating to escape velocity would require a significant burn of your thrusters, using fuel you need for the return journey. Changing course might take you into a more dangerous region of the rings. After a tense discussion with your crew, you decide to change course, moving toward the inner edge of the Cassini division. As your ship accelerates, you watch the large ice chunk pass harmlessly through the space you just vacated. But your relief is short-lived. New contact, Captain Santos reports. Multiple objects. Smaller, but more numerous. You're encountering something that researchers on Earth had theorized, but never confirmed. Debris streams within the ring gaps. When larger ring particles collide, they create clouds of smaller fragments that can persist for years, following complex orbits that sometimes take them into the supposedly clear regions between the main rings. Your ship is now threading its way through a cloud of debris ranging from pebble-sized chunks to pieces the size of basketballs. Each piece is a potential ship killer, and there are hundreds of them scattered across several cubic kilometers of space. This is like navigating through a minefield, Doctor. Rodriguez observes, and you realize he's not exaggerating. The debris cloud has no predictable pattern. Some pieces are clustered together, while others are scattered seemingly at random. Your pilot's skills are put to the ultimate test as she threads the ship between the larger chunks, while accepting that some impacts from smaller pieces are inevitable. The sound of impacts on your hull increases again, but now each impact carries more weight, literally and figuratively. These aren't the dust grain impacts you've grown accustomed to. These are chunk impacts, each one capable of causing real damage if it hits a critical system. Hull integrity down to 73%, Dr. Park reports. We've got microfractures developing in sections 7 and 12. You're learning that surviving in Saturn's rings isn't just about avoiding the big, obvious dangers. It's about managing the cumulative effect of thousands of small impacts, any one of which might be the one that finally compromises your ship's hull or damages a critical system. As you finally clear the debris cloud, your next objective comes into view. The sea ring, also known as the crepe ring. This innermost of Saturn's main rings presents a different set of challenges. The sea ring is much less dense than the A or B rings, but it extends much closer to Saturn's cloud tops, meaning you'll be operating in a stronger gravitational field and a more intense radiation environment. Radiation levels increasing significantly, Dr. Park reports as you descend toward the sea ring. We're now looking at about 200 times the lethal dose for an unprotected human. The stronger radiation isn't just a threat to biological systems. It's also a threat to your ship's electronics. High energy particles can cause single event upsets in computer systems, essentially flipping bits in computer memory and potentially causing software malfunctions or hardware failures. We're seeing intermittent glitches in the navigation computer, Captain Santos reports. Nothing critical yet, but we need to be prepared for the possibility of system failures. As you enter the sea ring, you encounter another phenomenon that makes survival here particularly challenging. Tidal forces. This close to Saturn, the difference in gravitational pull between your ship's nearest and farthest points from the planet creates measurable stress on your vessel's structure. The ship is experiencing differential gravitational stress, Dr. Rodriguez reports. It's like Saturn is trying to stretch us out. For a large ship like yours, the tidal forces aren't immediately dangerous, but they add another source of structural stress to a hull already weakened by thousands of particle impacts. and you realize that for a human body, the tidal forces this close to Saturn would be significantly more pronounced. Your sample collection in the sea ring reveals another surprise. The ring particles here aren't just ice and rock. They contain a higher proportion of organic compounds, complex carbon-based molecules that give some regions of the sea ring a reddish tint. These compounds, likely delivered by comets and asteroids over millions of years, create a more chemically complex environment. Some of these organic compounds are quite reactive, Doctor. Park notes as she analyzes your samples. In the presence of radiation and electrical discharges, they could form some pretty nasty chemical cocktails. You realize that surviving in Saturn's rings isn't just about avoiding physical impacts and radiation. It's also about avoiding exposure to potentially toxic chemical compounds that could form in the unique environment of the ring system. As your mission continues, you begin to encounter the effects of Saturn's complex magnetic field more directly. Unlike Earth's relatively simple dipolar magnetic field, Saturn's magnetosphere is tilted and asymmetric, creating regions where charged particles can be accelerated to incredible energies. We're entering a region of intense particle precipitation, Dr. Park announces. These particles are carrying energies equivalent to cosmic rays. The bombardment of high-energy particles creates another layer of danger. Not only do they contribute to the radiation dose your ship and crew are receiving, but they also interact with the ring particles themselves, causing them to emit secondary radiation and potentially altering their chemical composition. You watch in fascination as streams of charged particles follow Saturn's magnetic field lines, creating ghostly curtains of light that dance through the ring system. It's beautiful, but you know that each of those dancing lights represents a potentially lethal dose of radiation. The magnetic field is also affecting our navigation, Captain Santos reports. The compass is useless, and we're having to rely entirely on inertial guide. This creates another challenge for ring survival. Navigation becomes much more difficult when you can't rely on magnetic compass readings. The constantly changing magnetic field environment around Saturn means that electronic compass systems are unreliable at best. As you prepare to move to your next sampling location, you encounter one of the most dangerous phenomena in Saturn's ring system: a spoke. Spokes are mysterious, dark features that rotate with Saturn's magnetic field rather than following the orbital motions of the ring particles. They appear suddenly, persist for hours, and then fade away. And scientists still don't fully understand what causes them. We've got a spoke forming directly ahead of us, Dr. Rodriguez reports. It's about 10,000 kilometers long and growing. You watch in awe as a dark shadow spreads across the ring plane in front of you. The spoke appears to be made of tiny dust particles that have been electrically charged and lifted out of the ring plane by some interaction with Saturn's magnetic field. Should we try to go around it, you ask? Negative, Captain Santos replies. It's forming faster than we can maneuver around it. We're going to have to go through it. Entering the spoke is like flying into a cloud of electrically charged dust. The particles are much smaller than the typical ring particles, but they're present in much higher concentrations, and they're moving in complex patterns driven by electromagnetic forces rather than simple orbital mechanics. Visibility is dropping rapidly, Captain Santos reports, and we're showing massive electrostatic buildup. The spoke environment is unlike anything else in the ring system. The charged dust particles stick to your ship's hull, building up layers of material that affect your ship's aerodynamics and electrical properties. The constant electrical activity creates interference with your communications and navigation systems. We're getting false returns on all our sensors, Dr. Park reports. It's like trying to navigate in an electromagnetic storm. The psychological effect of the spoke is particularly intense. The swirling, electrically active dust creates an almost hypnotic display of lights and shadows. Combined with the sensor interference and communication difficulties, it creates a sense of disorientation that makes navigation extremely challenging. As you finally emerge from the spoke, you realize that you've been in Saturn's ring system for over 12 hours, and your ship is showing the cumulative effects of the harsh environment. Hull integrity is down to 65%. Several non-critical systems have failed due to radiation damage, and your fuel reserves are lower than planned due to the complex navigation requirements. We need to start thinking about extraction, Dr. Rodriguez suggests. We've pushed our luck about as far as we can, but before you can leave, you have one more objective: to investigate the F-ring, Saturn's narrow, twisted outer ring that's shepherded by two small moons, Prometheus and Pandora. The F-ring is one of the most dynamic features in the Saturn system. Constantly changing as the gravitational influence of its shepherd moons creates waves, kinks, and gaps in the ring material. As you approach the F-ring, you immediately notice that it's unlike the other rings you've explored. Instead of a broad, relatively uniform band of material, the F-ring is narrow and highly structured, with braids, clumps, and gaps that change on timescales of hours or days. This ring is like a living thing, you observe, watching as streams of particles weave in and out of the main ring core. It's the gravitational influence of the shepherd moons, Dr. Rodriguez explains. Prometheus and Pandora are constantly stirring up the ring material, creating the structures we're seeing. Your approach to the F-ring is complicated by the presence of the shepherd moons themselves. These small bodies, only about 100 kilometers across, create significant gravitational disturbances in their immediate vicinity. As you pass near Prometheus, you can actually see streams of ring particles being pulled toward the moon's gravitational well. We're seeing particle streams being accelerated to escape velocity, Dr. Park reports. Some of these particles are being ejected from the ring system entirely. This creates another hazard: high-velocity particles on escape trajectories. These particles aren't following predictable orbital paths like the main ring material. Instead, they're on hyperbolic trajectories that could take them anywhere in the Saturn system. Your sample collection from the F-ring proves to be the most challenging yet. The ring material here is highly dynamic, with particle velocities that vary significantly from the main orbital motion. Some particles are being accelerated by gravitational interactions with the shepherd moons, while others are being decelerated, creating a chaotic environment where collision velocities can be much higher than in the main rings. Impact energy is off the charts, Captain Santos reports. We just took a hit that was equivalent to a high-velocity rifle bullet. The higher impact energies in the F-ring environment mean that even relatively small particles pose a significant threat. Your ship's hull, already weakened by hours of bombardment in the main rings, is now taking hits that could potentially cause catastrophic failures. Hull breach in Section 4, Dr. Park announces. It's small, but we're losing atmosphere. This is the moment you've been dreading. Actual hull penetration. The breach is tiny, just a pinhole created by a high-velocity dust grain. But in the vacuum of space, Even a small hole can be deadly if not quickly sealed. Emergency hull patch deployed. Captain Santos reports, breach is sealed, but we can't take many more hits like that. You realize that you've reached the limits of what your ship can endure. The cumulative damage from hours in the ring environment has left your vessel vulnerable to catastrophic failure. Any further exploration could result in the loss of your ship and crew. But as you prepare to begin your extraction from the ring system, you encounter one final challenge. Getting out is almost as dangerous as getting in. The complex gravitational environment of Saturn's moon system means that there are very few safe trajectories that can take you from the inner ring system to escape velocity. We've got a problem with our planned extraction trajectory. The gravitational perturbations from Mimas and Enceladus have shifted our window. We're either going to have to wait 18 hours for the next opportunity, or take a much more dangerous path through the outer ring. Dan, waiting 18 more hours in your damaged ship isn't really an option. You don't have enough life support reserves, and your hull integrity continues to degrade with each passing hour. But the alternate trajectory would take you through some of the densest regions of the A ring, where particle bombardment would be intense. We don't have a choice, you decide. We take the dangerous path. As your ship begins its escape burn, threading between streams of ring particles while climbing out of Saturn's gravitational well, you reflect on what you've learned about ring survival. The rings of Saturn aren't just beautiful. They're dynamic, violent environments where the basic forces of physics, gravity, electromagnetism, and orbital mechanics combine to create conditions that are utterly hostile to human survival. The constant bombardment of particles, ranging from dust grains to house-sized chunks. The intense radiation environment. The complex gravitational interactions. The electrical activity, the chemical hazards, and the psychological stress of operating in such a hostile environment all combine to make Saturn's rings one of the most dangerous places in the solar system. As your ship finally clears the outer edge of the ice and begins its journey back to Earth, you look back at the magnificent ring system with a new appreciation for both its beauty and its danger. From a distance, the rings resume their serene appearance, giving no hint of the violence and chaos you've just experienced. Mission Control. This is Prometheus Zesident, you broadcast. Ring sampling mission complete. We're coming home. But as you settle in for the long journey back to Earth, you can't shake the feeling that you've only scratched the surface of understanding Saturn's rings. Each region you explored revealed new hazards and phenomena that hadn't been anticipated by Earth-based research. Differing shepherd-moon interactions, the spoke formation process, the debris streams in the Cassini division, the chemical complexity of the sea ring. Each discovery raised as many questions as it answered. You know, Dr. Rodriguez says as you review the mission data, I think we're going to need a much different approach for future ring missions. Maybe robotic probes that can withstand much higher levels of damage, or perhaps some kind of protective barrier technology. Dr. Park nods in agreement. The ring environment is just too hostile for extended human presence with current technology. We were lucky to get out with our lives. Captain Santos, still focused on the navigation displays, adds her own perspective. The thing that surprised me most was how dynamic everything is. From Earth, The rings look stable and unchanging, but up close, they're constantly in motion, constantly changing. It's like trying to navigate through a hurricane. As the hours pass, and Saturn grows smaller in your rear displays, you begin to process the psychological impact of your experience. The constant stress of operating in such a dangerous environment, the knowledge that any moment could bring catastrophic failure. The sensory overload of the electrical displays and particle bombardments. It all adds up to an experience that will stay with you for the rest of your life. I keep hearing the sound of particles hitting the hull. You admit to your crewmates, even though we're in clear space now, I can still hear that constant drumming. Post-traumatic stress, Dr. Park observes. It's common in extreme environments. The human brain isn't designed to process that level of constant threat. You realize that surviving Saturn's rings isn't just about having the right technology and enough fuel. It's also about having the psychological resilience to function effectively in an environment that's actively trying to kill you. The rings don't care about human ambitions or scientific curiosity. They're indifferent to human survival, following the cold laws of physics without regard for the biological systems, trying to navigate through them. As you document your experiences for the mission report, you're struck by how many different ways the ring environment could kill a human. The radiation would cause acute radiation syndrome within hours. The particle bombardment would shred any spacesuit or unprotected spacecraft. The electrical activity could cause fatal cardiac arrhythmias or burn out life support systems. The tidal forces could literally tear apart anything that gets too close to Saturn. The complex orbital mechanics could trap a spacecraft in an unstable orbit, leading to eventual collision with the planet or its moons. But perhaps most insidiously, the ring environment could kill through cumulative effects. The slow degradation of equipment, the gradual loss of hull integrity, the psychological breakdown from constant stress, the depletion of resources due to inefficient navigation. Amazing that anything survives in the rings at all, you comment, thinking about the small moonlets and shepherd moons that somehow manage to exist within the ring system. They survive because they're part of the system, Dr. Rodriguez points out. They've been shaped by billions of years of evolution within the ring environment. Humans are trying to enter an environment we didn't evolve for, using technology that wasn't designed for those specific conditions. This leads you to a sobering realization about human space exploration in general. The environments beyond Earth aren't just different from our home planet. Many of them are actively hostile to human life in ways that are difficult to fully appreciate until you experience them directly. Saturn's rings are beautiful from a distance, but up close, they're a reminder that the universe is largely indifferent to human survival. As your ship continues its journey home, you find yourself thinking about the broader implications of your experience. If humanity is ever going to establish a permanent presence in the outer solar system, we'll need to develop technology that can not just survive, but thrive in environments like Saturn's rings. We'll need better radiation shielding, more robust hull materials, more efficient propulsion systems, and perhaps most importantly, better psychological support systems for crews operating in such stressful conditions. Do you think humans will ever be able to live in the Saturn system? You ask your crewmates. Maybe, Dr. Park responds thoughtfully. But it would require a fundamental shift in how we approach space habitation. We need to think more like the ring particles themselves. accepting that the environment is dynamic and dangerous, and building systems that can adapt and survive rather than trying to impose Earth-like conditions. Nah. Captain Santos adds her own perspective. The key would be redundancy and repairability. In the ring environment, something is always getting damaged. You need systems that can heal themselves, repair themselves, or at least continue functioning with significant damage. Dr. Rodriguez nods. And we'd need to develop a much deeper understanding of ring dynamics. Our models and simulations were accurate to a point, but they missed a lot of the complexity we encountered. To safely operate in the rings long term, we'd need decades of additional research. As you review the data from your mission, you're struck by how much you learned in just a few hours of ring exploration. The spoke phenomenon, the debris streams, the electromagnetic effects, the chemical complexity. Each discovery added to the picture of an environment far more complex and dangerous than anyone had imagined. But you also realized that there's so much more to learn. You only explored a tiny fraction of Saturn's ring system, and each region you visited revealed unique characteristics and hazards. The G-ring, with its embedded moonlets and dust streams. The E-ring, created by geysers from Enceladus and extending far beyond the main ring system. The countless narrow ringlets and gaps, each with their own dynamics and mysteries. We're going to need follow-up missions, you realize. Lots of them. Each designed to study specific aspects of the ring environment. Agreed, Dr. Rodriguez says. But future missions should probably be robotic. The risk to human crews is just too high with current technology. This raises an interesting question about the role of human exploration in extremely hostile environments. There's something to be said for human adaptability and decision-making capability in complex, rapidly changing situations. Your crew made dozens of real-time decisions during your ring exploration that probably couldn't have been programmed into a robotic probe. But the cost, in terms of risk and resources, is enormous. As Saturn fades to a bright star in your rear displays, you find yourself already planning your next mission report and the recommendations you'll make for future ring exploration. Better shielding, more redundant systems, improved navigation algorithms, enhanced particle tracking capabilities. The list of needed improvements is long and expensive. But you also find yourself thinking about the broader philosophical implications of your experience. Humans have always been explorers, pushing into new environments and learning to survive in them. But space exploration is different from terrestrial exploration in fundamental ways. On Earth, even the most hostile environments, the deep ocean, the polar ice caps, the highest mountains, are still part of the same biosphere that produced us. They're challenging but not utterly alien. Space environments like Saturn's rings are truly alien. They operate according to physical principles that are familiar to us. But utterly foreign to our biological systems. They're beautiful in their own way, but they're also reminders that the universe is vast and largely indifferent to human concerns. Do you ever wonder if we're pushing too hard, too fast? You ask your crewmates. Maybe we need to develop better technology before we attempt missions like this. Every explorer faces that question. Captain Santos responds. the early ocean navigators, the polar explorers, the first aviators. They all had to balance the desire to explore against the reality of technological limitations. Dr. Park adds, but the difference is that terrestrial exploration mistakes usually just kill the explorers. Space exploration mistakes could set back human space exploration for decades, maybe centuries. Dr. Rodriguez has a different perspective. I think the bigger risk is not exploring. Every mission, even the dangerous ones, teaches us something we couldn't learn any other way. The data we've collected on this mission will inform ring science for decades to come. As your conversation continues, you realize that your experience in Saturn's rings has changed you in ways you're only beginning to understand. You've seen one of the most beautiful sights in the solar system. But you've also experienced firsthand just how hostile the universe can be to human life. It's a sobering reminder that Earth isn't just our home, it's our sanctuary, perhaps the only place in the universe where humans can exist naturally without artificial life support. But it's also inspired you to think about what it would take for humans to truly become a spacefaring species. Not just visitors to other worlds, but inhabitants of them. The challenges are enormous, but they're not insurmountable. They just require a long-term perspective and a willingness to accept that space exploration is fundamentally different from any other kind of exploration humans have ever undertaken. As your ship continues its journey home, you begin drafting your mission report, knowing that it will influence the direction of human space exploration for years to come. The rings of Saturn are beautiful, fascinating, and utterly deadly. They're also a reminder that the universe holds wonders and dangers in equal measure, and that human curiosity will always push us to explore both, regardless of the risks. Your experience in Saturn's rings has shown you that survival in such an environment isn't just about having the right equipment or enough fuel. It's about respecting the fundamental forces that shape these cosmic structures, understanding that they operate on scales and timelines that dwarf human experience, and accepting that sometimes the most important lesson is learning when to retreat and live to explore another day. But even as you head home, you can't shake the feeling that this is just the beginning. Saturn's rings have revealed their secrets reluctantly, and there are still so many questions left unanswered. The formation mechanisms, the long-term evolution, the detailed chemical composition, the electromagnetic phenomena. Each aspect requires further study, further exploration, further risks, and somewhere in the back of your mind, you're already planning your return. The journey back to Earth takes 3 years, and during that time, you and your crew become minor celebrities, the first humans to survive direct exploration of Saturn's rings. Your story captivates the public imagination. But fame comes with a price. Constant interviews, speaking engagements, and the pressure to downplay the dangers you faced in order to maintain public support for the space program. They don't want to hear about the reality. You confide to Dr. Park during one of your regular crew meetings. They want the sanitized version where we're brave heroes conquering space, not terrified explorers who barely made it out alive. The scientific community, however, hungers for the real details. Your mission data has revolutionized the understanding of ring dynamics, particle interactions, and the electromagnetic environment around Saturn. Papers based on your observations are being published monthly, each one revealing new aspects of the ring system's complexity. Dr. Rodriguez has become something of a celebrity himself in planetary science circles. His real-time observations of spoke formation and shepherd moon interactions have provided the first direct evidence for several theoretical models. But he's also the most vocal advocate for returning to Saturn with better equipped missions. "We barely scratched the surface," he tells a gathering of planetary scientists. What we learned in those few hours has raised hundreds of new questions. We need to go back, but we need to do it right. Captain Santos has taken a different path. The stress of navigating through the ring system has left her with what she quietly describes as space anxiety, a condition that's becoming increasingly common among deep space explorers. She's working with psychologists to develop better mental health protocols for extreme environment missions. "The thing people don't understand," she explains during a closed-door briefing at NASA headquarters, "is that space doesn't care about your bravery or your training or your equipment. It just is." And in places like Saturn's rings, is means violent, chaotic, and utterly indifferent to human survival. Yeah, as your ship finally enters Earth's orbital zone, you're struck by how different your home planet looks after your experience in the outer solar system. The blue marble that's inspired poets and philosophers for generations now looks fragile, precious, and utterly unique. You've seen the violence of Saturn's rings, the radiation-soaked moons of Jupiter, the frozen wastes of the outer planets. And now Earth looks like what it truly is, an oasis of life in a universe that's mostly hostile to biological systems. Your return to Earth is marked by parades, award ceremonies, and scientific conferences. You're presented with medals, honorary degrees, and keys to cities. But through it all, you carry the knowledge that you've seen something that changed your fundamental understanding of humanity's place in the universe. The mission debriefings take months. Every detail of your ring exploration is analyzed, cataloged, and cross-referenced. Engineers pore over the damage reports from your ship, using the data to design better hulls for future missions. Radiation specialists study your exposure records to develop improved shielding. Psychologists analyze your crew's performance under extreme stress to create better training protocols. The most important thing we learned, you tell a congressional hearing on space exploration funding, is that we're not ready for long-term human presence in environments like Saturn's rings. The technology gap is bigger than we thought, and the dangers are more complex than our models predicted. But rather than dampening enthusiasm for ring exploration, your mission has the opposite effect. The dramatic footage you captured, the samples you brought back, and the stories you tell have inspired a new generation of space explorers. Applications to astronaut training programs triple in the year following your return. More importantly, your mission has attracted serious industrial investment in the technologies needed for extreme environment space exploration. Companies that previously focused on Earth orbit operations are now developing radiation-hardened electronics, self-repairing hull materials, and advanced propulsion systems designed specifically for ring environments. 5 years after your return, the first follow-up mission launches. The Titan Explorer is a robotic probe, but it incorporates dozens of improvements based on your experiences. Advanced AI systems that can make real-time navigation decisions. Hull materials that can self-seal minor breaches. And instrument packages designed to function in the electromagnetic chaos of the ring environment. You watch the launch from mission control, now serving as a senior advisor for ring exploration missions. The probe's trajectory will take it through the same regions you explored, but with the advantage of knowing what to expect. Think it'll survive longer than we did? Captain Santos asks. She's also at mission control, now working as a mission planning specialist. It should, you reply. But the rings have probably changed since we were there. New spokes, different particle densities, evolved electromagnetic patterns. The rings are alive, in their own way. The Titan Explorer's mission exceeds all expectations. Protected by improved shielding and guided by AI systems that can react faster than human reflexes, it spends 6 months in the ring system, collecting data and samples that dwarf what your crew managed to gather. But it also confirms your assessment of the ring environment's hostility. By the end of its mission, the probe is barely functional, its hull perforated by thousands of particle impacts and its electronics degraded by radiation exposure. Even with all our improvements, Dr. Rodriguez notes as you review the probe's final data transmission, the rings are still trying to destroy anything that enters them. It's not malicious, it's just physics, but the effect is the same. The success of the Titan Explorer mission leads to approval for an even more ambitious project, the Saturn Ring Observatory, a permanent research station designed to study the ring system over periods of years rather than months. But the engineering challenges are enormous. How do you build a structure that can survive in the ring environment for extended periods? How do you supply and maintain it? How do you protect the human crews who would staff it? We're talking about building something that's part spacecraft, part bunker, and part self-repairing organism. You explain to a team of engineers and designers. It needs to be tough enough to survive constant bombardment, smart enough to avoid major hazards, and capable enough to conduct meaningful research. The design process takes 3 years and results in something that looks more like a biological cell than a traditional space station. The Saturn Ring Observatory is spherical, with multiple layers of self-healing hull materials, redundant life support systems, and a core that can separate from the outer structure if catastrophic damage occurs. Most importantly, it's designed to move, constantly adjusting its position to avoid dangerous particle streams, electromagnetic storms, and gravitational anomalies. But even with all these precautions, the question of human crews remains contentious. Your experience has shown that humans can function in the ring environment, but at enormous risk and with severe psychological consequences. Some argue that the observatory should be entirely robotic, controlled remotely from Earth or from a safer location in the Saturn system. The time delay makes real-time control impossible, you argue. During a design review meeting, ring environments change too quickly for remote control to be effective. You need human decision-making capability on site. Others disagree. The psychological stress you described suggests that human crews wouldn't be functional for extended periods, counters Dr. Jennifer Walsh, a space psychologist who studied your mission reports extensively. We might be able to rotate crews frequently, but that increases cost and complexity enormously. The debate continues for months, but eventually, a compromise emerges. The Saturn Ring Observatory will have the capability for human crews, but will normally operate robotically. Human teams would visit for specific research projects, or when situations arise that require real-time human decision-making. 10 years after your original mission, construction of the Saturn Ring Observatory begins. The project requires dozens of cargo missions to transport materials and equipment to the Saturn system, and the construction process itself is fraught with danger. You're part of the oversight team, reviewing construction progress and safety protocols from Earth. It's strange, you tell Dr. Park during one of your regular video calls. She's now directing the Planetary Sciences Institute and is heavily involved in planning the observatory's research program. We opened a door that we barely managed to get through alive, and now we're building a house in that same dangerous neighborhood. That's how exploration works, she replies. The first explorers map the territory and identify the hazards. The second wave figures out how to survive there. The third wave builds infrastructure. But as construction of the observatory nears completion, a new challenge emerges. Recent observations from Earth-based telescopes and the network of robotic probes, now operating throughout the Saturn system, show that the rings are changing more rapidly than previously thought. The spoke activity is increasing. New gaps are appearing in previously stable regions, and some ring particles are showing unexpected chemical evolution. The rings are responding to something, Dr. Rodriguez explains during an emergency planning session. Maybe solar cycle variations. Maybe long-term changes in Saturn's magnetic field. Maybe something we haven't thought of yet. But the ring environment is becoming more dynamic, more unpredictable. This creates a dilemma for the observatory project. The station has been designed for the ring environment as it existed during your original mission and the subsequent robotic surveys. But if the rings are evolving rapidly, those design assumptions might no longer be valid. We need to go back, you realize. A human crew needs to survey the current ring conditions before we deploy the observatory. The decision to mount another human mission to Saturn's rings is controversial. Your original crew barely survived the experience, and that was in relatively stable ring conditions. Sending humans into an environment that's becoming more chaotic seems like an unacceptable risk. But the alternative, deploying $1 billion research station into an environment we no longer understand, seems equally risky. After months of debate, the decision is made to proceed with a second human mission, but with significant improvements in technology and safety protocols. The Saturn Ring Survey 2 mission launches 15 years after your original expedition. The crew includes Captain Maria Santos, now a veteran ring navigator, along with 3 new astronauts who've trained specifically for ring environment operations. You remain on Earth, serving as mission advisor and hoping that your experiences will help keep the new crew safe. The new ship, Prometheus 12, incorporates every lesson learned from your original mission. The hull is 3 times thicker, with self-healing capabilities and emergency separation protocols. The propulsion system includes multiple redundant engines and enough fuel for extended operations. Most importantly, the ship carries advanced predictive software that can anticipate ring dynamics and suggest safe navigation routes. It's like comparing a modern submarine to a wooden sailing ship. Captain Santos reports as the new ship approaches Saturn. We're still in a dangerous environment, but we're much better equipped to handle it. But as Prometheus 12 enters the outer ring system, it becomes clear that the rings have indeed changed dramatically. The spoke activity has increased by an order of magnitude, with multiple spokes forming and dissipating across the ring plane simultaneously. New ringlets have appeared in previously empty regions, while some previously stable ring sections show signs of disruption. It's like the whole ring system is in upheaval, reports Dr. Amanda Chen, the mission's lead scientist. We're seeing particle streams, electromagnetic anomalies, and gravitational perturbations that weren't present during the original survey. I'd tell you the increased activity makes navigation significantly more challenging. Safe routes that existed during your original mission are now filled with particle streams or electromagnetic disturbances. The ship's advanced predictive software is struggling to keep up with the rapid changes in ring structure. The patterns are too complex for our models, Captain Santos admits during a tense crew meeting. We're essentially navigating blind through a system that's changing faster than we can map it. But the new crew has advantages that your original mission lacked. Better communication equipment allows them to maintain constant contact with the growing network of robotic probes scattered throughout the ring system. These probes serve as early warning systems, detecting dangerous phenomena and relaying the information to the human crew. More importantly, the new crew has been trained specifically for ring operations. Unlike your crew, which was adapted from general deep space exploration, these astronauts have spent years in simulators that recreate ring conditions. They know what to expect, and they're mentally prepared for the psychological challenges of ring navigation. The constant noise doesn't bother me as much, reports Dr. James Liu, the mission's physicist. I trained for 2 years with recordings of particle impacts playing in the background. It's actually kind of soothing now. As Prometheus 12 works its way through the ring system, collecting updated data and surveying conditions for the observatory deployment, the crew makes a startling discovery. The changes in ring structure aren't random. They appear to be related to increased activity in Saturn's magnetosphere, possibly triggered by changes in the solar wind or variations in Saturn's internal magnetic field. The rings are responding to electromagnetic forcing, Dr. Chen explains during a data transmission to Earth. The increased spoke activity, the new ringlets, the particle stream variations, they're all connected to changes in the magnetic field environment. This discovery has profound implications for the observatory project. If ring dynamics are driven by magnetospheric variations, then the ring environment might be predictable over longer timescales. Even if it appears chaotic in the short term, we might be able to forecast ring conditions weeks or months in advance. You realize during a mission planning session that would make observatory operations much safer and more efficient. But it also means that the observatory design needs to be updated to account for the dynamic nature of ring evolution. Fixed installations won't work in an environment that can change dramatically over periods of months or years. As the Prometheus 12 mission nears completion, the crew makes one final discovery that changes everything. Deep in the sea ring, in a region that appeared stable during your original mission, they encounter something unprecedented. A region where ring particles are being actively reorganized by what appears to be a standing wave in Saturn's magnetic field. It's like watching the rings rebuild themselves, Captain Santos reports. Particles are being sorted by size and composition, creating new structures that we've never seen before. The phenomenon is beautiful, but also deeply unsettling. It suggests that Saturn's rings are not the ancient, slowly evolving structures that scientists have long believed them to be. Instead, they might be dynamic systems that can reconfigure themselves in response to changes in their electromagnetic environment. We're not just studying the rings, Dr. Chen observes. We're watching them evolve in real time. This discovery forces a complete rethink of the observatory project. Rather than a fixed research station, the mission planners now envision a mobile platform that can move throughout the ring system, following the dynamic changes and documenting ring evolution as it occurs. We're not building a lighthouse, you tell the engineering team during a project review. We're building an exploration vessel that can live in the rings for extended periods. The redesign takes another 3 years, but the result is something unprecedented in space exploration. a vessel designed not just to visit an extreme environment, but to inhabit it. The Mobile Ring Observatory is part spacecraft, part research station, and part adaptive organism, capable of surviving and thriving in one of the most hostile environments in the solar system. 20 years after your original mission, the Mobile Ring Observatory begins operations in Saturn's rings. The first crew includes veterans of multiple ring missions, including Captain Santos, now in her third tour of the Saturn system. But you watched the deployment from Earth, now serving as director of the Deep Space Exploration Initiative. It's strange to think that it all started with one desperate mission that we barely survived. You tell Dr. Park during the deployment ceremony. Now we're essentially colonizing Saturn's rings. That's the nature of exploration, she replies. First you survive, then you understand, then you inhabit. The early reports from the Mobile Ring Observatory confirm that Saturn's rings are indeed one of the most dynamic environments in the solar system. The observatory crew documents the birth and death of ringlets, tracks the evolution of spoke patterns, and maps the complex interactions between ring particles and Saturn's magnetic field. But they also confirm your original assessment. The rings remain one of the most dangerous places in the solar system. Even with advanced technology and decades of experience, operating in the ring environment requires constant vigilance and frequent repairs to equipment damaged by particle bombardment and radiation exposure. We're not conquering the rings, Captain Santos reports during one of her regular status updates. We're learning to coexist with them. Every day brings new challenges, new dangers, and new wonders. As the years pass, the Mobile Ring Observatory becomes humanity's first permanent outpost in the outer solar system. The crew rotations every 18 months ensure that fresh minds and bodies are available to handle the psychological and physical stresses of ring operations. But the observatory also becomes something more. A symbol of humanity's determination to push beyond the comfortable confines of Earth and establish a presence throughout the solar system. Your role has evolved as well. Now, in your 70s, you serve as an elder statesman of ring exploration, mentoring new astronauts and helping to plan even more ambitious missions. But you also serve as a guardian of institutional memory, ensuring that the hard lessons learned during your original mission aren't forgotten as ring operations become more routine. The rings haven't become safer. They remind each new class of ring astronauts, we've just gotten better at surviving them. But they're still trying to kill anything that enters them, and they'll succeed if we ever become complacent. Your warnings prove prescient when the Mobile Ring Observatory experiences its first major crisis in its 5th year of operation. A solar storm triggers unprecedented spoke activity throughout the ring system, creating electromagnetic conditions that overwhelm the observatory's shielding and disrupt its navigation systems. We're essentially flying blind through an electromagnetic hurricane, Captain Santos reports during the crisis. She's now the observatory's permanent commander, having adapted to ring operations better than anyone anticipated. The crisis lasts for 3 weeks, during which the observatory crew must rely on manual navigation and emergency procedures to avoid catastrophic collisions with ring particles. 2 crew members suffer radiation poisoning, and the observatory's hull integrity drops to dangerous levels before the storm finally subsides. It was like your original mission all over again. Captain Santos tells you during her post-crisis debrief. All our technology and experience didn't matter when the rings decided to show us who's really in charge. The crisis leads to another round of improvements in ring operations technology. But it also serves as a reminder that Saturn's rings remain fundamentally hostile to human presence. No amount of technology or experience can completely eliminate the risks of operating in such an extreme environment. But the crisis also demonstrates something important about human adaptability. The observatory crew not only survived the electromagnetic storm, but continued their scientific observations throughout the crisis. Their data from the event provides unprecedented insights into ring dynamics during extreme conditions. Humans bring something to ring exploration that robots can't. You tell a gathering of space scientists. Adaptability, creativity, and the ability to make intuitive leaps in understanding. The question isn't whether we should have humans in the rings. It's how to keep them alive while they're there. As your career winds down, you find yourself reflecting on the legacy of your original mission. What began as a desperate survival story has evolved into humanity's first sustained presence in the outer solar system. The Mobile Ring Observatory has been joined by similar installations throughout the Saturn system, research stations on Titan and Enceladus, mining operations on smaller moons, and a growing network of automated probes and sensors. But Saturn's rings remain the crown jewel of outer solar system exploration. Their beauty, their complexity, and their hostility continue to attract the best and brightest of human explorers. Each new mission brings fresh discoveries and new challenges, but also adds to humanity's growing understanding of one of the universe's most spectacular phenomena. On your 80th birthday, you receive a special gift from the current crew of the Mobile Ring Observatory. A small sample of ring material collected from the exact location where your original mission nearly ended in disaster. The sample is mounted in a clear crystal, allowing you to see the individual ice particles that make up Saturn's magnificent rings. It's beautiful, you tell Dr. Park, who's joined you for the birthday celebration. But I can't look at it without remembering the sound of those particles hitting our hull. That's what makes it precious, she replies. It's not just a scientific sample. It's a piece of your story, a reminder of what it took to bring that material back to Earth. As you hold the sample up to the light, you think about all the people who made humanity's presence in Saturn's rings possible. Your original crew, who shared the terror and wonder of that first exploration. The engineers who designed a better spacecraft based on your experiences. The scientists who turned your observations into theoretical understanding. The astronauts who followed in your footsteps. Each mission building on the knowledge gained from previous expeditions. But most of all, you think about the rings themselves. Those magnificent, deadly bands of ice and rock that have challenged human ingenuity and courage for decades. They're still there. Still beautiful. Still dangerous. Still offering new mysteries for future generations to explore. Do you ever regret going? Dr. Park asks. You consider the question carefully. The mission cost you years of your life to stress-related aging. It left you with psychological scars that never fully healed. It changed your fundamental understanding of humanity's place in the universe, making Earth seem both more precious and more fragile. But it also gave you experiences that no other human being had ever had. You've seen Saturn's rings from the inside, watched spokes form and dissipate, felt the ship shake under the bombardment of ring particles, and navigated through the electromagnetic storms of the ring system. You've pushed human exploration to its limits and helped establish humanity's first foothold in the outer solar system. No, You finally answered. I don't regret it. The rings tried to kill us, and they nearly succeeded. But we survived, and we learned, and we came back. That's what exploration is about. Pushing beyond the known, accepting the risks, and bringing knowledge back for the benefit of all humanity. As the years pass, and you enter your final decade, you watch with pride as humanity's presence in Saturn's rings grows and evolves. New technologies make operations safer and more efficient. New discoveries continue to reveal the complexity and beauty of the ring system. New generations of explorers take on the challenge of operating in one of the universe's most hostile environments. But the fundamental truth remains unchanged. Saturn's rings are beautiful, fascinating, and utterly deadly. They represent both the promise and the peril of human space exploration. They're a reminder that the universe is vast, complex, and largely indifferent to human ambitions. But they're also proof that human curiosity, ingenuity, and courage can overcome even the most extreme challenges. In your final interview, before retiring from public life, a young journalist asks you what advice you have for future ring explorers. Respect the rings, you tell her. They're not just a scientific phenomenon or a tourist destination. They're a living system with their own dynamics and dangers. They've been there for millions of years before humans evolved, and they'll be there long after we're gone. We're visitors in their domain, and we need to act accordingly. But don't let the danger stop you from exploring. You continue. The rings have secrets we've barely begun to understand. Each mission reveals new wonders and new mysteries. As long as humans remain curious about the universe around us, we'll keep pushing into dangerous places like Saturn's rings. Your final words prove prophetic. Long after your death, humanity continues to explore and inhabit Saturn's rings. New missions push deeper into the ring system, exploring regions that were too dangerous for your generation's technology. New discoveries continue to reveal the complexity and beauty of these cosmic structures. But every mission begins with a briefing that includes your story. The first humans to enter Saturn's rings and live to tell about it. Your experiences serve as both inspiration and warning for new generations of explorers. The rings are beautiful, but they're also deadly. They offer incredible rewards, but they demand respect. And somewhere in the vast expanse of Saturn's rings, the Mobile Ring Observatory continues its mission. Humanity's permanent outpost in one of the most dangerous and beautiful places in the solar system. Its crews change every 18 months, but its mission continues: to explore, to understand, and to prove that human curiosity can overcome even the most extreme challenges the universe can offer. The rings of Saturn killed no one during your original mission, but they easily could have. They remain one of the most hostile environments in the solar system, a place where the basic laws of physics combine to create conditions that are utterly antagonistic to human survival. But they're also one of the most beautiful and scientifically important features of our solar system, a reminder that the universe is full of wonders that are worth almost any risk to explore. Your legacy lives on in every mission that ventures into Saturn's rings, in every discovery made by ring explorers, and in every young person who looks up at Saturn and dreams of exploring its magnificent, deadly ring. You proved that humans could survive in one of the most extreme environments in the solar system. But more importantly, you proved that they could thrive there, learn there, and establish a permanent presence there. The rings of Saturn will always be dangerous, They will always be hostile to human life, but thanks to your courage and that of all who followed, they will never again be impossible to explore. And that, perhaps, is the greatest victory of all, turning the impossible into the merely incredibly difficult, and proving once again that human curiosity and determination know no bounds. So, the next time you look up at Saturn through a telescope and see those beautiful, serene rings, remember that they're not peaceful at all. They're cosmic storm systems where ice particles move at bullet speeds, where radiation levels would put to magnetic forces create lightning storms that could fry any electronic device, and where the simple act of existing requires a constant battle against the fundamental forces of physics. But also remember that humans have been there, survived there, and learned there. We've taken one of the most beautiful and deadly places in the solar system and made it a frontier for human exploration. The rings of Saturn represent both the ultimate challenge and the ultimate reward of space exploration. A place so dangerous that survival seems impossible, yet so magnificent that we can't resist trying. That's why you wouldn't survive Saturn's rings. Not because humans aren't capable of amazing things, but because the rings represent nature at its most spectacular and most unforgiving. They're a reminder that the universe is vast, beautiful, and largely indifferent to our survival. But they're also proof that human ingenuity, courage, and determination can find a way to explore even the most impossible places. And who knows, maybe someday, with better technology and more experience, Saturn's rings won't be a death trap, but a destination. Maybe future generations will look back at our early ring missions the way we look back at the first polar expeditions or the first flights, dangerous pioneering efforts that opened up new frontiers for human exploration. Until then, Saturn's rings remain one of the universe's most beautiful death traps. Combined to create conditions that are utterly hostile to human survival, yet so scientifically important and visually stunning that we can't help but keep going back. Thanks for joining us on this journey to one of the most dangerous places in the solar system. Next time, we'll explore another cosmic death trap that makes Saturn's rings look like a peaceful vacation destination. Until then, keep looking up, but maybe appreciate the safety and comfort of our little blue marble just a bit more.